everyone. How is everyone doing? It's the last session before the lunch, so I hope I will keep you awake for this hour. I will try to start with something scary so that you don't fall asleep very quickly. Anyone remembers these 3 rules and where they're coming from? The first rule is never expose them to the bright light. The next rule is keep them away from the water. And the last one, the most important rule, never ever feed them after midnight. Gremlins, yeah. So for those of you who haven't seen Gremlins, you should. Amazing movie, it's like 1984. Really cool, about this cute creature called Mogwai. And it's very nice and peaceful and kind of all the joy of life if you follow those rules. If you break those rules, what happens? Mogwai starts multiplying. And then those evil creatures, gremlins, they spread. They are very difficult to control and stop, and they just take over the world. And in my opinion, the data is someone like that. So when we start sending the data into a pipeline, it can be an innocent event, like someone logged into the system, or the payment was received and then it goes through the system. But then we start converting and sending those events to other downstream systems, and sometimes we log that stuff for the future. Sometimes we put it into later analytics, or we send it to train LLMs. And the more the data goes through those cycles, the more potential private issues we get, because those other creatures which contain private information of ours or of our users actually continues their life even when the pipeline, the visible part, is over. Who of you actually deal with systems which work with private data of the customers? Oh, we have some hands. And who of you are concerned of the privacy of your data? Who of you are just paranoid of privacy of your data? Okay, we have a good number of hands. So let me ask you this question. Would you trust a social media platform which logs in the information about the username and password in the logs protocols later? And all the developers of that company who owns that social media can later go and access and see the password of the users. Would you trust that? No, almost no one. Who of you are using Facebook? Facebook is known to log in those passwords and username in their logs. Not only Facebook, actually GitHub and Twitter also had the same. Facebook had to pay 91 million euros for the GDPR issue, but it's not uncommon for companies, and I don't know. I don't think it was an evil purpose for them to log that information and make it accessible to developers within the company. Maybe it was just negligence, but it doesn't matter at the end of the day, because that information is private and we don't want to share it. Another example is where sometimes we assume the data is anonymous. So we removed everything. There is no real name and password, like in those log cases, but still, it can be not safe. So Netflix had a very interesting experiment. So they shared a data set, and you can still find the data set on Kaggle, a data set of 100 million records about the ratings which users gave to the movies. So a huge stuff, but technically just had information about some customer ID, about the rating, and a date per movie. Anyone spots anything suspicious in this particular information related to privacy? Do you think you would be able to identify who stands behind that customer ID just with this amount of data? Yep. Do you have some hands? So Netflix was quite successful, actually, with improving their algorithm. So they shared it with developers. Developers suggested better algorithms and experiments based on that data. And they were even thinking of making the next iteration of this experiment. However, they ran into a couple of lawsuits. So some researchers managed to identify customers within this previous data set. And how they did it, they just found another data set on IMDb, where people also rate the movies. And I never rate the movies. I'm too lazy for that. But apparently those people who do, they do it on both Netflix, and then they go and rate it on IMDb. But not all the movies, because some movies you don't want to share that you watch that movies just to hide maybe some certain preferences or interests. But if we overlap two data sets now, the public and the private one, and we do it in a vague manner. So we have a date. We don't really compare exactly the timestamp to timestamp, but just kind of vaguely. And then the movies which people watched create kind of this behavior fingerprint. And you just kind of match those and you find people. So de-anonymizing data is not as difficult, and there is a lot of ways where privacy can go wrong. And today I wanted to talk about this issue. My name is Olena. I work for Confluent, and on a day-to-day basis, I work with technologies such as Apache Kafka, Apache Flink, Apache Iceberg, because I see a lot of customers and a lot of use cases, how data is used, I also pretty concerned about the privacy of the data I live on the internet. That's why also I wanted to raise this awareness and share maybe some techniques, what is being used right now in the industry to prevent those private leaks information, and in general, where you should get more concerned or paranoid. Streaming systems, any of you actually work with Apache Kafka here? We have some hands. Anyone knows Apache Flink? Have some good, because Apache Flink is like the baby of Berlin. I think it was when the university here developed. So for those of you who are not dealing with streaming pipelines on the daily basis, actually you are dealing with them. When I was just getting right now a coffee in a nearby coffee shop, I paid with my card. So, information, actually, a lot of systems behind those transactions involve systems such as Apache Kafka. So the data, the event which happens, goes into the pipeline, and then that information quickly is used to identify if it's a fraud or I am actually really in Berlin buying that coffee. And we do a lot of transformation on the data. So that single event then ends up being copied somewhere, put maybe to some analytics, put somewhere else, to data lakes, put to normal OLTP databases. Also, we use a lot of different applications to consume the data, like dashboards and so on. So a lot of things are happening with a usage of a lot of different applications. And often we actually don't even know what happens downstream with that data. Of course, the pipeline, it's kind of in stages. So we also have a power at different stages to stop that propagation of the private data if we feel that is necessary. But the whole idea of the streaming pipeline, it's always on. It's just like that river of the data pieces which go through the system. It's like it's impossible. It's designed to be as fast as possible, the lower latency, the higher throughput. And with the fan out, like one event, multiple destination, technically if you feed it the private data and you don't control where that private data lands, and if it lands into, for example, to train the model using that private information, or it lands into logs, having that passwords to log in into the system, then it creates a privacy nightmare. So let's look how we can deal with it. And we go with some more boring steps to some more exciting ones. The boring part is like foundation. So here, to have the control over the system, we actually already have a lot of pieces in place. For example, identity and access control. So here we want to make sure that any actors which can sense the data in our system has the minimum permissions to do that action, but not more. Whether the actor is a person or some kind of an API call, or maybe it's an agent, we want to do the same. It should be the minimum permissions we give to that particular actor. Then encryption. We use several types of encryptions to protect the data, so at least no one can eavesdrop on that information. So at rest, like information written on my laptop actually gets automatically encrypted. In transit, TLS, we are using it all the time. We are using MTLS, where we want really like to make sure that we identify both client and the server. There is a different variety of kind of encryption flavors. The futuristic flavor, which I haven't seen being used so far in the cloud, sadly, but it's quite interesting, is homomorphic encryption. No, anyone heard about homomorphic encryption? No? Oh, there is one person. So homomorphic encryption, imagine like usually to make an action on the data, for example, you have a salary, and that salary is stored somewhere, and that data is encrypted. And then your manager says, that person deserves a salary increase, 20%. So to perform that operation and to increase your salary and save it as a new state in the database, right now what we have to do, we have to decrypt the value, perform that 20% increase, encrypt the value, store it again in the database if we keep it encrypted. So homomorphic encryption allows to perform those operations on the encrypted value. So it is encrypted in the way that you change it, you apply some mathematical functions. It's kind of futuristic because even though it's possible and we have different flavors of that, number of operations we can perform, different operations, but the cost is performance. It's still kind of a very expensive operation. So homomorphic, super cool stuff. Then we have data governance and policy. This is where we need to know what is our data and which properties are personally identifiable information and which ones are safer to share. So we can set the rules for that, and we can also kind of have a better control and to know where the data is going. And finally, the data ingress and data egress. So this is where when the data comes into the system and when the data leaves from the system, this is where we need to be extra careful. So what tools exist to help us with the privacy of the information? The lowest level, something you might be running on a daily basis, is data masking and tokenization. So starting with data masking. So when, again, I was like printing this receipt today from the coffee, I only saw on the credit card which was used last 4 characters, last 4 numbers, and the rest were stars. So this is technically data masking. This is where a part of the value will be just starred out or hidden, or the complete value can be hidden. And the whole idea is kind of to help hide those private information when you see, for example, the whole dashboard, and maybe you don't want to allow the admin to see all the properties in the dashboard, but only some of them, then you can mask out according to some logic and some rules. So data masking is very easy to implement, and even though there is different varieties how you mask it, but technically you lose the value once you mask it out, unless it's only for UI. So it's not really something which will go through the stream and then later you can recover that value. You just lost it. So often it's used for the UI purposes. So on the dashboards or when you print something out. So you are not really exposing those values. So imagine if we have, for example, a table of the customer table and we have some values. Do we have any SQL people here? Anyone who speaks SQL? Oh, there are some. Using SQL here for simplicity, but imagine we have this data store, and then with data masking, the easy part is we just kind of substitute those values according to some pattern. So any language would be sufficient. You of course need to grab that the data which goes through the pipeline, but you can convert that. So it's quite a fast operation, quite an easy concept to follow. At the end, if you then expose the data, it's not really like revealing anything, any personal details. The data masking, for example, you can also have the rules. Like this is just example how we use it within the cloud. We just set, like for example, the PI rule, and if you encounter the private property, then you have to mask it out when you, for example, it goes through the connector into some database. But data masking is quite limited. That's why a more interesting concept is tokenization. Tokenization is where we are not really hiding part of the value. We're replacing the value with something somewhat random, ideally not mathematically deductible from that value, but something like, for example, email, whatever, like it will be johndoe@gmail.com will become the token with some number. And the whole point is that if you have your token vault, and in the token vault you have the original value and you have the token. And then you start working with the tokens, but those tokens have meaning only if you have access to the token vault. There are different ways of how we can actually do the tokenization. For example, encryption can be technically used as a token, but not really ideal. So ideally, you want to have something where there is no mathematical way to come back to the value. You never know what kind of encryptions will get broken later. Like hashing is definitely not tokenization, and I will show some real example later where it was broken. But yeah, so the tokens, something random, not mathematically deductible from the value. There are like low value tokens, those which will only make sense if you have access to the token vault. So, for example, if token vault is destroyed, then you can never revert the data to original. But also there are high value tokens, and those, for example, are used when you are like logging into AWS and they give you a token. That's also a token. Tokens are a bit more tricky to work with because you have to have a possibility to work with a token vault. And if you are, so you will have to manage, for example, the keys, the encryption key of the token vault, and in general to control then the whole process end to end. However, tokenization is one of the probably most widely used way of protecting that personal information and keeping it away, but still keeping it usable in case you want to revert and use the original value instead. However, in that Netflix example which I shared, they kind of had the token, so customer ID there was exactly the token per customer, not their name. So technically, there is a way where you seemingly removed all personal information, and still it is possible to identify the person. So in Netflix example, it was just another data set which was mapped, and then the people, like you could match the real person behind that customer ID. And here the most powerful, like the combination of customer ID and date was probably the most powerful combination for the fingerprint. And technically the timestamps, because we don't, again, not comparing exact timestamp to timestamp, we vaguely look at the date of the events and we match that if we have, for example, per customer, I don't know, like 20, 30 of movies being rated during the different timestamps. So that timestamp on its own can be a really important piece to re-identifying information. Then let me share with you a couple of more examples of where personal information was re-identified later. The next example is when AOL released some 20 million of search queries. So they just took the chunk of the 3-month period, and all the search stuff which people were looking for went to the internet. That became a pretty big story, so that AOL actually got into the list of 101 dumb moments of that year. And it's kind of like it's all sad, in my opinion, because all that information, all those data sets, they are really helpful for us to experiment and to see the real data behind the scenes. However, it doesn't really eliminate all the potential privacy problems. So with AOL, the fun part is, and it took me actually, so there are still pieces of that information on the internet, and it took me quite long to scroll that to find anything which I can screenshot and put on the slide, which is not illegal, embarrassing, or just like super weird to read. Because like, so if you search for the search log per customer, you kind of go into the life of that person. So you just know what kind of challenges, like if for example, your search logs from Google or from whatever your system you are using right now shared, it will give such a huge window into your life. So there are some movies made based on some characters from those search logs and also some theater plays. So it was kind of a stuff which got into the history. Something significantly more recent, which is from US, so the context here matters. I'm not sure it's reproducible 100% in Germany, just because of how the population is distributed. But Latanya Sweeney, she is quite busy raising this awareness that governments, sometimes they do share private information. Here in Massachusetts, they shared information of the government employees, the medical information, and their families publicly. And of course, they removed the obvious personal identifiers, such as name and so on. But Latanya Sweeney showed that actually you can easily link a person just by knowing the zip code, birthdays, and gender of that person. And I heard similar stories actually across the world where people share, and if it's a small, for example, town, and they share, actually it was probably from my friend recently in Seattle. It's just like, so they send us the dates of she was fired. She is like 40 years old, and they're like, you might be tempted to go to the court because you're fired because of ageism, but here is a list of people who were fired with you and their date of birth and also their salaries. So, and then like you kind of can link those things very, very together like quickly. So, so that's why like all the public information which innocently shared is evil. I mean, evil because you can easily like get back to the people. Then Strava. Anyone uses here Strava? Ooh, cool. So Strava, nothing wrong about Strava. Strava is amazing. But at some point of time, and they, in my opinion, they did nothing wrong. They were sharing the beautiful aggregated information of how users are using their application across the world. And accidentally, the location of military bases by USA were shared as well. So apparently those military people also do a lot of sports and also like to track it. Beautiful, no? So this is where the aggregated data, and this is very sensitive data for US, was revealed in a very like easy way, and I'm quite sure that Strava might not even recognize it at the moment they shared, and of course it's not their responsibility to prevent people using those devices. It's more like responsibility of the military employees. But also you never know when the data will become sensitive. That's also like at the moment when these people use those trackers, there was like no danger. But then the data evolves and it gets somewhere to the place where it's possible to re-identify it. It's also the challenge with how we treat the data, because we never know what properties will become sensitive and what other mechanism, like another data set, or the decision of the company to share aggregated data will be revealed, and then it will compromise that early, seemingly innocent action. Then about hashing, New York taxi data, they revealed a lot of information on individual taxi trips. And they actually tried also to anonymize the drivers. So they put it like a hash for the car number, and those yellow cars in New York City, they have a certain pattern. So the hashing in general is also not so difficult to reverse back. But with that particular approach, so if you look at the car number and there is a certain pattern, so there is not that many options, and there's not that very variety of the values which can be like numbers per that car. That's why it was quite easy to create the hash table and to map the hash to the original value. So mathematically, it's just like a couple of minutes of the current computer. So that's why hashing is never really a good way to tokenize or to hide information. Same can be said with encryption if we believe that encryption can be broken later. So most probably, even if New York City taxi data would be tokenized in a different way, it would still be possible to reverse it back. So it's also not that would be secured. But in general, this situation was pretty sad, because so they shared the information about the car, plus they shared the geolocation. So if you have then the amount of trips per driver, you know the driver's salary, you know the driver common routes. For the passengers, you know who likes to go to the nightclubs and where they end up on a certain, and because you also have the addresses, you can also reverse it to the where people live. So in general, data doesn't need these exact names or some passport details to identify people. And there is if you go into the research papers and kind of Wikipedia and everything else, this is just like the names of different identification approaches. There is no unique definitions which are very, very strict. So, but there are a number of ways how we can reverse the seemingly anonymized information to the original individuals. That's why there are some other advanced techniques which are more and more used, and especially right now with LLMs. They are more complex and more tricky to use. However, k-anonymity, anyone used or heard about k-anonymity? We have some hands. So k-anonymity is like for when you have a data set, you want to make sure that for every record there must be at least k individuals who have the same attributes, so that you cannot single out that person. And it sounds amazing. There are some approaches how to perform that. However, it's more like inspirational metric, because technically, mathematically, it's very difficult to prove. There are different concepts, and I was talking to people, and they keep this budget of the values they have to have this attribute visible. So there are different ways how people go around it. Still, not an easy method to do, even though still practical to kind of try at least to aim there. Bucketing goes well with almost any techniques, including k-anonymity, is where instead of having information with exact values, we just put it into a bucket. So you kind of go, it's from that value to another value. You go like less precise, not GPS, but like a city, part of the city. And you also screw like the time, like not a timestamp, but something a bit less specific. And those, again, are not super difficult to implement. The only tricky part is how do you define those buckets in advance, especially if the data is constantly changing. So this is more like about business logic and about predicting where your values will go into the future. But if bucketing seems to be too strict, there is another way. It's just kind of like ruining data, like spoiling data, poisoning data on purpose. And this one, actually, I have seen it using in the LLM trainings. And I was talking to a person some months ago who is working with the medical records. Medical records are actually then used to train LLMs, which is quite important task, but also because they have to go with regulations of different governments, they cannot really share exact information, so they have to change it, and they poison it on purpose. And there are different algorithms how you do it, and the challenge here is how much you need to poison the data so that it really stays, so you can never go back to the person, but at the same time that it doesn't poison the whole data set when you start training a model or running analytics. And here, of course, we know that we will ruin the exact row, so it's not to be used in OLTP scenarios. So this is for OLAP, for analytics, or for training the models where the huge volume of data compensates that kind of imprecision per row. Obviously, still imprecisions can lead into some incorrect conclusions, and here we need to find this good balance. There are different ways how you can, there are different algorithms actually, but you can also just randomize the value with some noise, and especially the time, for example, maybe if the Netflix dataset would have that randomization per the date of the rating, that would have helped to prevent this kind of matching across with IMDb dataset. And the last one is just ignoring the whole problem altogether. And this works when we use the real data for something like development environments. We don't need that, and I really hope that it's not a common practice, but of course it does exist, where we actually use the customer data to validate the systems, to do something where we actually could just have some kind of mocked values. And there are different ways how we can mock those values, but the whole idea here is just we totally go away from the real properties, so you cannot really train data or do something else, but this is an example of shadow traffic, how they do it. They allow to mimic the data and have lots of different rules and lots of different generators. But then you just don't have that problem of private information, at least for those limited amount of use cases where you don't have to have real data, but the format of the data is something you are looking for. But all in all, this is where there is no really good answer for that privacy issue, because the more data we try to remove, the less overall the data set becomes valuable. So we want actually to keep the data set somehow to be valuable, and we want, of course, to remove the personal identifiers sooner for those use cases where you don't really need to have them. But at the end of the day, you will have to kind of have this decision matrix and really to see how much this data is worth all the legal consequences or all the issues with the privacy later. So yeah, it's sadly not really a single solution, at least not on the moment, and I don't see where it will become a single solution. And on this slide, I try to put all those things which I mentioned so far. I do hope that, and especially here in Berlin, in Germany, we do care about private information, and I hope that we can all together contribute to preventing some stupid decisions being made and information being spilled out, so that we protect the personal identifiers of our customers as well as of our own. So, and that's it from me. Thank you for listening.
Do we have any questions from the audience?
Hello. Thank you. That was a wonderful talk. My question goes to where you were talking about tokenization. So the N of taxi drivers is small and so predictable going through a simple hash function. We have things like adding salt and, there's encryption and all that stuff, but you mentioned that this would not be sufficient either. And I wondered, did you have a recommendation or a way of approaching tokenization, or is that actually just a hard problem to solve from your perspective?
So I would go with the random value, and encryption technically can work. It's just like thinking about quantum computing and other like encryption. Like it's like we don't know what will be in 5 years, like in 10 years. So, but technical encryption is used. So if that's the easiest way to create the token, and I mean, you are again balancing the effort and the value, and yeah, so then it's possible to use. But I would just go with some random, of course, yeah, like the random algorithm which is not revertible, which is not very, very strongly linked to mathematics, which you can come back to. But I mean, technically speaking, everything can be somehow reverted, but something more random than encryption. Because encryption is like we go, and maybe correct me if I'm wrong, like we go still from value A to value B, but it's kind of deterministic how we will get. It will be the same value B from value A all the time, right? So but I would go with something random. Like random is the best.
Okay.
Yeah, thank you for the talk. It was really, really nice, especially with all the pictures. So I wanted to ask, basically, the tokenization, is it just like creating a reference table? So you always have to have it there?
Yes, exactly. It's a reference table which you keep private. So that's another like point of weakness there. But technically, only person who has, or like actor who has access to that reference table knows the value, no one else.
Okay, so like if you do role-based access on just the, I don't know, schema where this table is, it should technically be safe.
There's also, I think, a different roles-based access. Those are different concepts. So role-based access will help you in any case, and I think you should have it in all the scenarios. And role-based access can actually help you for the access to the full data as well as the token vault. But I think the token vault is more like a separate concept. So those can be used together, but also powerful concepts, like powerful tools apart.
Thanks, wonderful talk. I get it that the same customer does have to get another token or an unlinked token in another data set that may be derived from the same operation, so that it can't be linked.
So that's, if I understand you right, so if we are using the same use case, and within the same use case, we can make a decision whether it should be deterministic tokenization or a random one. So for example, Netflix dataset, they had a deterministic. Per customer, the customer ID is always same, right? They could have went, okay, like we actually have the data set and then just like random values for customer ID, but then you lose all the meaning behind the data. So within the use case, within kind of usually because we want actually to be able to merge and to link the data. So if you have you store the tokens still in a secret place and technically limit amount of people who access it, the usage, but you still have that, and the tokens then with their power, you can link multiple, you can perform operations, you can still work with the data to see any tendencies or anything else if you keep this kind of name of the customer to the token per customer consistent and deterministic, like it's one-to-one conversion. If you decide that, okay, you actually want to be more secure and we will get either completely random values, but then you lose totally like the whole combination and the whole connections between the data within a single data set, you can do it. And again, like here, you have just to make the decision.
Thank you very much, Olena.
Thank you so much.